Yeah, and you didn't give it back. I got it. Yeah. In my hand right now. That's probably not. I broke it. So.
All right, 7-5, day 2.
Oh, hold up.
We weren't going very fast or anything. No, wait.
I'm not waiting. Number 1. Okay, we're going to have one very similar to the box with the 2 ropes coming off of it. So we've got a crate supported by 2 ropes. Crate.
Doing examples?
Mostly. Supported by 2 ropes. One rope makes an angle of 46 degrees, 20 minutes to the horizontal. The other rope is horizontal. Find the. I'm just going to draw the picture. Okay. So here's this crate. And then there's 2 ropes. Yep. One rope makes an angle of 46 degrees. Well, I'm going to go 46.3 degrees. The other rope, it said, is pulling completely horizontal. Who would ever try to lift a crate this way is beyond me. Yeah. Completely horizontal. Let's see, one rope. And has this one has 89.6 pounds of force on it.
Or maybe they're done with the crate.
Find the weight of the crate and the tension in the horizontal rope. And the tension in the horizontal rope. Okay, so there's our picture. So the physics going on here, you see the 2 ropes pulling out, supporting the weight of this crate. So when it's asking you to find the weight of the crate, what did you just learn today about that one that I did? What represents the weight of the crate? The resultant. So when they say find the weight of the crate, it's the resultant of these 2 ropes. They have to support the weight. So when it says find the weight, you are finding the resultant. And what do I have to do to find a resultant? If these 2 forces are representing vectors, and they're tail to tail right now,
Draw the box.
you have to slide them and put them head to tail. Okay, 89.6, yep, pounds. All right, before I slide, what should I find? The inside angle here. What's the relationship for these 2 angles? 180, because you got a straight line coming through here. If you think about the top of the box being horizontal. So what's 180 minus the 46.3? 133.7 degrees. Okay, so I'm going to slide this horizontal rope. I can slide either one. Doesn't matter which one you want me to slide. The horizontal one or the 89.6 one?
89.
And you can slide whatever one you want. Our picture's going to look the same. I'll use H for horizontal. I know, because the weight's going to be perpendicular here. I didn't know how big to make that one, but I know the weight is going to be, because the gravity is going to be opposite the gravity. So the weight is going to be, the resultant's right here. Okay, how do I get this angle back over here?
It is.
2 ways to get it.
Opposite,
Oh, it's
interior,
90
whatever.
minus. It'd be 90 minus 46.3.
No, it is 46.
Okay, I know.
It is 46 point. This one would be 46.3. Okay. The resultant. The weight of the box is the resultant. W equals R here. I said weight, but it is resultant.
133.7 minus 46.3, right?
I just use alternate interior transferred in, or it's 180 minus the 133.7 because of the parallelogram. The consecutive angles have to add up to 180. Okay. So right now, I've got a side and this angle. What else is in this picture because of the positioning of the weight being straight up and down?
A 90-degree angle.
A 90-degree angle right here. So now we've got angle, angle, side. Run your program and answer the two questions. What's the angle across going to be? This is the only one that matters, which angle you put in first.
90.
The 90 is across from the known side, so it's got to be the 90. And then the 46.3. And then the 89.6 is the side. And it should be kicking back an angle and two sides. Those two sides answer the question, but you got to get them in the right order. So how much weight is the horizontal rope supporting, and how much weight does the box actually have? What's 64.8?
Your weight.
The weight is 64.8. Do we agree with that?
Yes.
Okay. How much weight was the horizontal rope holding?
The horizontal rope is 61.9. I agree with that.
You agree with that?
61. So that would be the tension.
Mm-hmm. Yep, because that would be the smaller angle, yes. I agree with both of those.
Wait, what do you mean smaller angle?
Because the 46.3 is here, and this is going to be like 42 point something. So looking at that right triangle there. Okay, now we're going to be a weatherman. This is the part that gets confusing, the airplane up in the sky with some wind pushing it around. So we've got our airplane and wind problems to talk about. Airplane.
Is this example 2?
Not yet. You don't know enough about this to do example 2 yet. Airplane and wind problems. All right, so what you have, there's two forces working up in the sky. You've got the direction that the plane's headed with its speed behind it as one vector. They call that the airspeed. So one vector is going to be the airspeed vector. And then the other vector is wind. And when you add those two together, you get a resultant, but that resultant is called the ground speed. So there's just labels that are attached to these. So right now I've got my wind and airspeed tail to tail. So when I make my resultant, so I'm going to slide the wind over. Or you can slide the airspeed up, whichever one you want to do. You don't have to do both. The resultant vector is called the ground speed vector. It's how fast the plane looks in the sky to the person standing on the ground. It's like watching someone on one of those moving sidewalk things. Have you ever been in an airport and you see people walk on those moving sidewalks? Or walk up an escalator or down an escalator? You know, you look back and it looks like they're really going fast. But that person doesn't feel like they're going fast because they're just taking their normal steps. But you got the two speeds working together. And that's what's happening here. You've got your motor speed on the plane, plus you've got the wind pushing it. It can push it and make it faster, or it can push it and make it slower. Depends on which way you're going. So this ground speed is what it actually looks like from the person on the ground, how fast the plane's actually moving. Okay, now wind. We got to be a weatherman for a minute. Wind direction. So we're going to look at the weatherman, what the weatherman says, and then what we actually have to draw. So what do I want to call that? The vector. Okay. If the weatherman says there, what? Yep, little table. Oh yeah, there's a little table here. We're going to do a couple things.
Is wind direction like the title of the
Yes.
table? Okay.
Yep.
Thank you.
Very good. You understand my notes, my chicken scratch. Okay, if the weatherman says there's a south wind today, which way is the wind actually blowing? Which way is the force moving? When he says there's a south wind today of 25 miles an hour, do you know? It is blowing into the north. It's coming, he tells you where the wind is coming from. So when he says there's a south wind, it's blowing, it's pushing toward the north. So which way is the force, the vector moving? Up to the north. This is the vector that I would have to draw in my picture. It's blowing to the north. So weatherman tells you where it's coming from, but we got to draw it which way the force is moving, the direction that it's going in. Make sense?
Yeah.
So if he says there's an east wind today, which way is the wind actually blowing and pushing stuff? Toward the west. So now if it's blowing from a 45-degree bearing, which way is it actually blowing? And this is a bearing. We're going to actually draw the picture. You see bearing. Bearings are coming back. Need a dotted line north for bearings. Then it's clockwise, 45 degrees. So what he is telling me is this wind is blowing in from that direction. So here's my wind. Wind. See my wind blowing? Yeah. So which way is it actually going?
It's actually going southwest.
It's actually going southwest.
What?
This is the tricky part. That's my arrow showing the wind coming in from that direction. Blow, blow, blow. So which way is it actually going? The force is pushing it toward me back this way. So, what direction is this at? What bearing is this vector at? How do I figure that out? You're going to give me a shortcut here in a minute after you understand it. How many degrees is it from where it's blowing from to where I draw it into?
180.
It's 180. So if this was 45 plus the 180, what direction is this actually at? 45 plus 180. I drew my vector at 225. So, the 180? Yep, because when I'm blowing from, see the straight line? Where it's blowing from and where I draw it into is a straight line. So that means from this side to this side is 180. Correct? Just forget that. From this to this is 180. I want to know the bearing that I draw it at. The bearing is from the, how far over is it from the north all the way over to where I actually drew this vector. So I had to add those two together. So what's going to happen? Anytime you have wind, we're going to make a 180-degree correction. Because the weatherman tells us where it comes from. I need to draw it where it's blowing into. That's always going to make a 180-degree line. So if I say it's from X degrees, you are going to draw it in X plus 180. You always have to correct the wind. My table kind of got screwed up on my picture, but it's going to be x plus 180. So you always have to correct the wind by adding 180 degrees to it when you draw it in your picture. All right, are you ready for this?
Yeah.
I think we got 2 of these. And you probably may not have many of these today, like maybe 1 or 2, and tomorrow's going to be a lot of these, but I want to spend 2 days so it has time to sink in. Okay. Number 2. We'll keep them simple today. This is number 14. Okay. Okay, a pilot wants to fly on a bearing of 74.9 degrees. By flying due east a 42 mile per hour wind blowing from the south puts him on course. Find the airspeed and ground speed. Okay, your best bet on these airplane problems is to identify the 3 forces, your airspeed, your wind, and your ground speed, and pull everything out that you know. So, airspeed. What do I know about this vector?
It is.
Well, let's see if any. Tell me what you do know here. Ground speed and wind. What do you know about the wind?
The wind is gonna go 254.9 degrees.
Tell me what you know about the wind.
74.9.
Nope.
No, it's 42.
It's 42 miles per hour, so that's how much magnitude it has. 42 miles per hour. What else do I know about it? It's coming from the south, so which way am I going to draw it? Correct it. Which way am I going to draw it? I'm going to draw it north. Okay, so I know everything I need to know about the wind vector. Okay. It says he wants to fly on a bearing of 74.9 degrees. Which vector would that be if that's where I want to end up? Which is the resulting vector of where I actually end up with my plane in the sky? Is that the airspeed or is that the ground speed?
Ground speed.
That's the ground speed. So this 74.9 degrees is my ground speed vector. I don't know how fast it is, but I know its direction. Okay?
Wait, why did you say something?
Because it's coming from the south, I'm going to draw it to the north. We always have to correct that direction. So they told me it was a south wind, but when I draw it in my picture, I know the south wind means it's pushing me to the north because it's coming from behind me, from the south, pushing me north. Okay, it says by flying due east, he ends up on this 74.9 degree bearing by the wind. So that means that was his airspeed vector is east. Yep, told you these were tough. Should probably start with a little bit easier one, but that's okay. We'll get through it. All right, and it's airspeed plus wind equals ground speed all the time. airspeed added to wind equals ground speed. So you always want to have your airspeed and wind head to tail. Yep. So I know where the resultant's going to be. I know what direction that's going to be at. That will help me with my triangle.
So since the airspeed east, do we draw it west?
No, just wind gets corrected. That's the only one. All right, so it doesn't matter whether I start with airspeed or wind. I want to add these two together, and the resultant is ground speed. So, start in the middle of your paper, come down, draw a point. This is where I'm going to start. And I don't care. Do you want to start with airspeed or do you want to start with wind? Airspeed. Okay, what do I know about the airspeed vector?
It's east.
It's east, so I can draw an east. I'll use little a for airspeed. Okay, now I want to add on the wind. Where should I draw the wind vector at if I'm adding this to this vector?
At the end of the airspeed.
At the tail.
At the arrowhead. Remember, head to tail. So I want to draw the wind right here. Which way do I draw the wind?
North.
North. Wind is probably very minimal compared to the speed of the plane, so I'll make it short. And what else do I know about that wind?
42.
42. Okay, so when I add those two together, that means I started here and I finished over here. This is my resultant, this is my ground speed vector, G for ground speed. R for resultant, G for ground speed, they're the same thing. Okay, what do I know about that ground speed vector?
74.
It's at a direction of 74.9. These are bearings. If you're a pilot, you deal in bearings. So what would I need to add to this picture to show that 74.9? I need a dotted line north to show that this plane is actually on a bearing of 74.9 degrees. Because right now, I only know one part of this triangle here. I need two more parts before we can run a program. What other two parts do I know?
We can 90 degree angle. Get that
I got the
inside
90.
angle.
And we're going to get this inside angle. Well, how do I get this inside angle?
90 minus 74.9, which is 15.1.
Which is 15.1. So now what program can you run?
We can angle at the top.
Angle, angle, side. And I asked for two things. I wanted the airspeed, that's the engine speed on the plane, and then the ground speed, how fast is it actually moving in the sky. And you can see from our picture that the wind is giving it a little bit extra speed. What? I do not know that. All right, what did you guys get for how airspeed?
161.2.
So
That's ground speed.
Oh, no, it isn't.
the ground speed should be the bigger one.
Yeah. it
What's
is.
the bigger one?
160. The options were 42, 155, and 161. The
Thank
other
you.
angle is 74.9.
155 is the airspeed.
Yeah. 155.7.
Here's the side I know, the 15.1. 42 should not have come up. You've got a bad program.
Me?
Yeah.
No, I didn't. 42 didn't come up.
Oh.
I'm just saying the options for all the sides.
Oh, the sides. Okay.
Yeah.
So the airspeed has to be the 155.
Wait, it would be 156.
156 because of rounding. And then the ground speed would be the 161. Any questions on where those came from?
But that other angle is 170 or 74, so wouldn't the bigger side?
The 90, this is across from the 90.
Oh.
You're looking at the 42 is across from the 15.1.
Yeah.
There you go.
Okay.
That was your confusion.
Thank you.
Got that cleared up.
Okay.
Anybody else confused?
Looks like miles per hour.
Yep, miles per hour. Are we good on that one? Let's try one more.
Is that the last one?
This is it. Let's see. Oh, it's not even an airplane one. Let's see. Starting at point A. Point A. A ship sails 18.5 kilometers on a bearing of 189. So we're going to sail 18.5 kilometers on 189 degree bearing. From that point, we're going to turn.
That's not how you spell bearing. Is it B-E-R-R?
No, it's B-E-A-R.
No, it's not. There's no possible. Like a bear?
Well, let's see.
Bearing, like the bearing straight? Yeah, that's true.
Unless these authors spelled bearing wrong every single time, that's how you spell it. Okay.
They're wrong.
Turn and sail 47.8 kilometers on a bearing of 317.
We got bearings on bearings?
Yep. Find the distance from point A. Find distance from the start. So this isn't any vectors going on here. This is just a two-legged trip. Okay. Both on bearings. So here's my point A, which I'm going to draw in the middle of my paper. I don't know which way this picture is going to grow. Okay. On a bearing of 189, what should I put in my paper?
North line.
North line. So I need to show a 189 degree rotation. I'm going to go right through my letter A. Nice. 180 is directly below and then 9 degrees over. So here's the first leg of my trip. From the north, I got to turn 189 degrees. What direction would I be going? What don't you get? Well, because bearings are always from the north and clockwise. Always. North and clockwise. Okay.
The other bearing on the...
Now from here I've got to turn. So I need another north reference line so I can find my bearings, I guess. Would be a good way to put it. So I'm going to put in another north line. How many degrees am I going to rotate around? 317. That's quite a bit. Because that's 270. That's up here. Now here's this trip. And it's much, much longer than the other one.
For what?
And I got to put my two distances on there. 47.8 and 18.5. And our goal is to find the distance from where I am now back to the start.
Could you just tell me where the 270 is?
Tell me where the 270 is directly here.
Okay.
East. 90, 180, 270.
Yeah, but you're only going up a little bit.
Well, it doesn't matter. Quit picking on my picture.
Look, it's easier to draw if you make them exaggerated.
This is what's telling me 317. That's all. It's all good.
Get that other angle in there. It just
I'll show you.
looks like you're going up like 280.
Oh, wow. Quit picking on my picture.
Oh, then you just use staff.
Once we figure out this angle here, you will be able to find the angle that's chopped up down here. You're going to find it in two pieces. One part is easy to find. What's the easy part to find?
360 minus 317.
Yep, this part's easy because that makes a full circle. So this side of it's going to be 360 minus 317. And what does that come out to be over there?
43.
43 degrees. The other side is going to be found with alternate interior angles. And we're going to get alternate interior by extending this line right here, this north-south line.
Can't you just roll with what you have though, right there?
No, because I don't know this part of the angle. My triangle is here. I need the whole angle in my triangle.
It'll be
Oh.
9 degrees.
How much is this angle right here?
43.
Try again.
Wait, no.
9.
9. Where's 9 coming from?
180.
181.
Because it's 180 to the south line. I went to 189. So that's 9 degrees. Then alternate interior, it just transfers in. This angle is 9 degrees.
I'd say 9 degrees.
9 degrees. Do you see the alternate interior happening?
Yeah. Where's the 43? I mean, I guess.
The red part.
No, I mean, where, can you put the other 43? Oh, I
The other 43.
You know, the all whatever.
Not thinking there's another 43 anywhere in here.
That's not the one that's alternate.
Oh, this is outside. This is alternate interior has to be in between my two parallel lines.
Sweet mother of God.
In between, inside, interior.
Triangles inside the triangle.
Nope.
Are you seeing things? Yes. I get what you're saying, but you're wrong.
Okay.
I know what I mean. I'm saying I know where.
She understands where she's talking, but
I know what you're saying.
apparently you're not correct. Okay, we're ready for SAS.
Why is it 40?
What do you want it to be? I don't know how to answer that either.
Would it just be 52 because of 43 plus 9? Yes.
Yes, you got to add these together, so your angle is going to be 52.
Should have just started with that.
Go ahead.
60 minus 317. Oh, is that 40?
That's the 43.
Oh, okay.
That's why it's right above there.
So 50 what?
2.
52.
And then our two sides, 47.8 and the 18.5.
39.2.
That's what I got too.
39.2?
Yep.
Okay, work hard on these. Don't just say, oh, I don't get it. You got to work really, really hard.
Okay. I don't have time to work.
Let's see. Today, Monday.
Where are you going? I'm going to go either get stitches or more stairs.
Just get it cut off.
I will. Just get it cut off. Oh.
We'll do more airplane tomorrow. Oh, I gotta shut this off.